One of the most common questions about the origin of the universe is also one of the simplest to ask, yet among the most difficult to answer. Where did the Big Bang happen? Did it occur at a specific point in space? Is there a place in the universe from which everything originated? And if so, would it be possible to indicate it, locate it, observe it? These questions arise from a very widespread image of the origin of the cosmos. The Big Bang is often described as an enormous explosion, a violent event that hurled matter into space from a central point. But this representation, while effective from a popular science perspective, risks creating confusion. To truly understand where and how the universe originated, it is necessary to clarify what we really mean when we talk about the Big Bang. The Big Bang, in fact, is not an explosion in the traditional sense of the term. When one thinks of an explosion, one imagines something that occurs at a specific point in space and projects fragments outward, occupying regions of space that were previously empty. This is what happens, for example, in the explosion of a supernova. In that case, the explosion has a well-defined source. It is possible to indicate where it occurred and observe the material moving away from that point. It therefore makes perfect sense to ask where the explosion happened. Many people ask the same question about the Big Bang precisely because they imagine it as an event of this kind, an explosion that occurred at a point in space from which matter was thrown in all directions, giving rise to the expansion of the universe. But the origin and expansion of the universe do not work this way at all. Astronomical observations for more than a century now show that in whatever direction one looks, distant galaxies are moving away. This recession follows a very precise relationship, known as Hubble's law, according to which more distant galaxies recede at greater speeds than nearer ones. At first glance, this behavior might resemble fragments of an explosion moving away from a central point. However, this interpretation is misleading. According to Einstein's theory of general relativity and the cosmological model that follows from it, galaxies are not moving away because something hurled them through space. In reality, it is space itself that is expanding. Galaxies, on average, are not moving through space like projectiles launched by an explosion. It is the space between them that is stretching, increasing the distances between them. This expansion does not occur within a larger space. The universe, by definition, is everything that exists. It is not contained within anything else. If something existed outside the universe, that too would be part of the universe itself. As a consequence, space does not expand by occupying an external void. It is space itself that changes scale, everywhere, in the same way. A fundamental aspect of this expansion is that it has no center. Wherever one is located in the universe, the same phenomenon is observed. All distant galaxies are moving away according to Hubble's law. From any other galaxy, the universe would appear the same. This means that there is no privileged point, no special location from which everything originated. Observations confirm this idea. When the distribution of matter is studied on enormous cosmic scales, the universe appears, on average, uniform in all directions. There is no region with an extraordinarily higher density that could be identified as the center of a gigantic explosion. There is also another fundamental observation. Looking far into space also means looking back in time. Light takes billions of years to reach us, and by observing increasingly distant galaxies, we observe epochs increasingly closer to the beginning of cosmic expansion. Going back in time, it is found that the density and temperature of the universe progressively increase. This happens in every direction one observes. At a certain point, one reaches the cosmic microwave background, a faint radiation that permeates the entire universe and represents direct evidence of a primordial phase in which the universe was extremely hot and dense. This radiation arrives from every direction with virtually identical characteristics. This means that, about 14 billion years ago, the entire observable universe was in the same physical state, regardless of direction. In other words, the Big Bang did not happen in a specific place, but everywhere at the same time. Even the region of space that we occupy today was part of that initial phase. It is sometimes said that the entire universe was concentrated in a tiny point. This statement, however, is also imprecise. We do not know whether the universe as a whole is finite or infinite. We only know that the part of the universe we can observe is finite because light has had a limited amount of time to reach us. The observable universe, going back in time, was indeed much smaller. But this applies to any point in space. It does not necessarily mean that the entire universe was concentrated in a single point. If the universe is infinite today, it was infinite in the past as well. Infinity, even when extremely dense, remains infinite. In light of all this, to the question, where did the Big Bang happen? The correct answer is surprisingly simple. It happened everywhere. There is no center of the universe. There is no privileged point. Every region of space took part at the same cosmic instant in the beginning of the expansion. And it is precisely this characteristic that makes the origin of the universe one of the most fascinating and counterintuitive phenomena ever discovered by science.